Alright, hi ladies and gentlemen. Tonight we're going to take a look at all of the laws of exponents that we have done in this unit. And there are many, so I put them together in a nice little format so we can look at all the laws together. Keep in mind there's a lot of different ways to do that, and we looked at shortcuts and we looked at doing simplifying exponents the long way. And we're going to do this review of the laws to get ready for a test on Thursday. We'll have another review tomorrow night as well. Okay, so here's all the laws that we have done, or all the properties we have done. The zero exponent power, what happens if the exponent is negative, what's the shortcut for multiplication and division, what if we have a power to a power, which means we have parentheses on the inside and with an exponent and an exponent on the outside, the product of a power, here's the product of x and y, and the quotient, that just means division. So we'll take a look at the first two, and again, we've done these in our notes before, but we'll go over them again anyway. Keep in mind that anything to the zero power is equal to 1. Doesn't matter how big or how small the number is, anything to the zero power is 1. So if we're doing 72 to the zero power, 72 to the zero power is 1. However, in example number 2, the only thing being raised to the power of 0 is the x, so this 5 is going to stay the same. 5 doesn't have an exponent, so we can give it a 1 if we want to. But this just means 5x to the 0 is equal to 1, so our answer is 5. The second law that we looked at was the negative exponent. And this is the one that gave us really small numbers. It gave us decimals. So when we have an exponent that's negative, remember that we write it as a fraction, and then we flip it. So keep our fraction bar, the x goes on the bottom, the exponent becomes positive, and then 1 stays on the top. So in these two examples here, negative 5x to the negative 2, there's really a multiplication sign in here, so we're going to treat these as two different things. This does not have a negative exponent, so we're just going to write it over 1. We'll put these both over 1. So negative 5 over 1 stays the same. The x to the negative 2, and again we wrote that as a fraction, does have a negative exponent, so the 1's going to go on top, and the x to the second is going to go on the bottom. And then we can multiply to simplify these fractions. 5 times 1 is 5, and 1 times x squared is x squared, and that's our answer. So in example number 2, again, it looks kind of complicated, but it's not. You know how to do this. I'm going to circle the, I'm just going to erase these right here to get them out of our way. I'm going to circle, it's already in a fraction, the parts of the fraction that have positive exponents. So this has a positive exponent, it's 4 to the first power. This has a positive exponent, it's k squared. And this has a positive exponent, it's 8 to the first power. So we're just going to rewrite that fraction bar. The 4 is going to stay where it is because it has a positive exponent. The k squared is going to stay where it is because it has an positive exponent, and so is the 8. What's going to change is the k to the negative 5. That's going to come up on top, and we're going to have a positive exponent. So if you look at this fraction part right here, if this fraction were by itself, what could we simplify 4/8 to? We can simplify 4/8 to 1/2, and then we have k squared times k to the 5th. So we have 2 k's here. This means k times k. This means k times k times k times k times k. So what we're left with is k to the 7th. And that's our final answer. Okay, so here's another multiplication property. Let's go over to our property over here. This is just in general terms. If we have two numbers with the same base, all we have to do is multiply the exponents. I'm going to show you the long way, but this just means x to the a times b. So in our example over here, h squared times h to the 6th, h squared means we have 2 h's, h to the 6th means I have 6, so if I count them all up, I end up with 8 of them, and we get h to the 8th. And we could just go ahead and add these two exponents, but sometimes it's easier to write them out the long way. Okay, example number 2, we are going to have to rearrange to make it easier. So all of this is multiplication. There's a multiplication sign between everything, and since multiplication is commutative, we can move these around. So I'm going to rewrite this one. I'm going to put the numbers first, so -2 times 7. Then I'm going to look for other bases of a, and I have an a squared and an a to the 3rd, so that's a squared times a to the 3rd. And then I have a b here and a b here, and they don't have an exponent, so we're going to give it a 1. So that means b times b. We'll work out each part individually. -2 times 7 is -14. A squared times a to the 3rd, remember, is 2 a's and then 1, 2, 3 a's, so we end up with a to the 5th. And then b to the 1st times b to the 1st, we have 2 b's, and so we end up with b to the 2nd power, and that's our final answer. Okay, let's take a look at the next law, which is division. And division can be written in 2 ways, with a fraction bar or with the division sign. But this is where we had exponents cancel each other out, if you remember. So what we ended up doing for both of these was we end up subtracting the exponents. It's a minus b. So for example, over here we have 27x to the 5th divided by 42 to the x. I'm going to write this one out the long way. So this is 27 times x times x times x times x times x. And the bottom one is 42 times x. These two are going to cancel. We can simplify 27 over 42 by dividing by 3. And we get 9 over 14. And how many x's are we left with? We're left with 4 x's, so it would be x to the 4th. And that's our final answer. We could also write it as 9 over 14, x to the 4th. That would be fine too. Our next property is the power to a power, and that just means that we have an exponent raised to an exponent. And that's where we use something similar to the distributive property. We multiplied this exponent by that exponent right there, and we got a times b. So over here in example number 1, this just means I need x squared 3 times. So it's x squared times x squared times x squared. If we wanted to write that out the long way, it's x times x times x times x times x times x. And we end up with x to the 6th power. Or we could just multiply 3 times 2. In example number 2, we have -2m to the 5th power. The -2 does not have an exponent, so we're going to give it a 1. So I'm going to write this again out the long way. -2m to the 5th power squared means I need -2m to the 5th power times -2m to the 5th power times m to the 3rd. If I regroup these so that I have like bases together, the -2 and the -2 I can write as negative 2 times 2, and then I have m to the 5th times m to the 5th times m to the 3rd. That's supposed to be a 3, sorry. Negative 2 times negative 2 is a positive 4. I have 5 m's plus another 5 m's plus 3 more, so that's going to give me m to the 13th. 4m to the 13th, and if you can't see the 13, it's right there. I'll rewrite it again because it's kind of hard to see. So before m to the 13th. All right, 2 more rules to go. The product to a power, and product just means multiplication, so we're multiplying these two together. And again, if it doesn't have an exponent, you give it a 1. And we do the same thing as the power to a power. We just multiply that together, and we get x. 1 times a is a, and then y, 1 times a is also a. And it works similarly to a quotient to a power, and again, if we don't have an exponent, we give it 1, and we multiply a times that exponent and a times that exponent. We keep the fraction. 1 times a is a, and 1 times a is a. So let's go ahead and take a look at those examples. So as I said, if it doesn't have an exponent, you give it a 1. So the long way, this means 3 times x times 3 times x, because we need it 2 times. If we write it out, that grouping like bases together, it's 3 times x times x. 3 times 3 is 9. And x times x is x squared. If you wanted to do the shortcut, and again, this didn't have an exponent, so we needed to give it a 1, it would be 2 times 1 and 1 times 1, or 1 times 2, and we would still get 3 squared times x squared, and 3 squared is 9. Number 2, we're going to write out the long way as well. We need this term 3 times, so it's 4x squared times 4x squared times 4x squared. I'm going to group like bases together, so I'm going to group my 4's together, which is 4 times 4 times 4, and my x's together, which is x squared times x squared times x squared. 4 times 4 times 4 is going to give us 64. And then I have, this is x times x times x times x times x times x, and I end up with x to the 6th. And that is my final answer. Okay, last 2 examples, and I really hope you're listening to this and that you do well on the test on Thursday. If it doesn't have an exponent, you give it a 1. And again, I'm going to write this out the long way. It means 5 over 6 2 times. 5 times 5 is 25. 6 times 6 is 36. And we are done. 2x divided by 4 to the 3rd. So we need 2x divided by 4 3 times. So it's 2x over 4 times 2x over 4 times 2x over 4. I'm going to group like bases together, so when I rewrite this, I'm going to write it as one big fraction. So I have like bases. It's 2 times 2 times 2. And then my like base here is x, so that's x times x times x. And down here, we have 4 times 4 times 4. Two times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. X times x times x is x to the 3rd. And in the previous problem, we already said that 4 times 4 times 4 is 64. I'll accept your answer like that, but you can also simplify 8 over 64. If we divide 8 by 8 and 64 by 8, we get 1 over 8 x cubed. You can write it like that. And again, this answer is fine. Or we can write it as 1 over 8x to the third. Okay, we are going to practice with this in class tomorrow, and we are going to practice with more laws of exponents on Wednesday to get ready for our test on Thursday. So next is the secret question. Somewhere on my website, it tells you where I used to live and how long I've lived in North Carolina. If you can find that, the first person in class on Tuesday that comes up to me and answers those two questions will get, I guess, a lollipop. All right, thank you and have a great night.